Okay, hey everybody. So another day of dev video. Probably only going to do one of these today. So we're going to go ahead and get back to working on our extended block data. What we're going to do in this video is quickly just create a way to synchronize data between the client and the server, and that's pretty much the only thing we're going to do. Before we get into that, I have created a master to-do list for the organization. It's something I probably should have done a while ago. I'm slowly working on this. It's only about an hour worth of work, so this shows a bit of the tasks that I foresee needing to be done sooner than later. It doesn't contain everything, as there actually is a huge amount of stuff that still needs to be done. For example, Volts Engine by itself, I still have to rewrite most of it to accommodate for the newer versions of Minecraft and try to future-proof things. But right now, I've listed things like the heat map, gas map, fluid map, different maps we're going to start using to store data. Now, my note, these are, even though these are meant to represent a map of the game world, they are basically glorified data structures. For example, the gas map and fluid map most likely are actually going to be the same map. What's going to happen is there'll just be a slight differentiation between how they're accessed. The gas map is going to store gases stored in the air. This is going to be used for oxygen for our space mod whenever we decide to make it. I'm hoping to get a few other developers to kind of pitch in and use this. It's been a bit hard. Nobody really wants to use the code at all. Everybody who makes mods is like, I got my own way to do things, and really would love to have the community here kind of back up Volts Engine and build mods for it. Heat map is something that we definitely need to get working on. This is something that's going to be continuously used. Almost every machine is going to use it. Both the fusion and fission reactors built up in atomic science are going to use the heat map to actually generate energy. Um, they're also going to end up using the fluid map as well. So what the main purpose of the fluid map, by the way, is so we can store complicated amounts of data without hindering the game too badly. We want to be able to use about 50, 60 different types of fluids, different pressures and everything else. This will be stored via the fluid map. It'll store our pressures, our flow rates, our directions. Same with the gas map. It'll do all that stuff. So that's the reason why this one says same as gas map, but for liquids, pretty much. Block metadata is what we're going to be working on today. We just got to finish implementing and sync it to the client. We're done. Radar map, it only needs to be unit tested. It's already functional. We've been using it for ICBM for a while. The sentry guns that shoot down the missiles have been using the radar map to identify missiles and kill them. Actually, that was the old one. The new one's just flat out detect them. We'll have to work on that. In-game manual is something that's going to be coming out rather soon. I'm going to take the code from the Access GUI and I'm going to flip it over to an in-game manual. Before I get that done, though, I'm going to be replacing that grave key. So grave key is how you open up the access system. We're going to replace this with a larger GUI. That way, when you click it, it'll open up and it'll go, okay, do you want to use the access system, the command system, the debug data, the tracking data. So the tracking data, by the way, is things like we're tracking FPS, TPS, RAM, CPU. That way, you as a user or mod pack maker or server owner can sit there and look at the thing going, we're fluctuating on the CPU a little tough. We're running out of RAM. These items over here are using too much RAM and stuff like that. It'll also give you access to the configs to quickly edit them. It'll also be what we use for the wiki, which is the end-game manual is what it's going to be called. We'll try to add tie-in for other people's manuals too, so you won't have to carry around all the people's books to access their manuals. You'll just be able to open up the manual and go, okay, I want the computer craft manual, and it'll open up and it'll show you all the information. We'll probably put a notebook in there. We'll probably throw a couple other things in there just for fun because, I mean, you got a big GUI. You can do whatever you want with it. We'll toy with that and play around with that. Radiation map is something we're going to be working on as well here. Biggest thing is I just got to finish my research for this one. The data structures are already implemented. At least the base code is for them. But I can't decide if I want to use a long, a short, a double, whatever. That's the same problem with the heat map. It's the reason I haven't dove down into it. Is I haven't figured out what we're going to use for the units for it. Because we need to be able to store values in the millions, but at the same time we need to be able to store low values, and that's complicated. I may end up using a long for this, but the problem with using a long is that it is 64 bits per block, and then you times that by 256 to get the world height, 16, and then times by 16, then you're looking at about 4 million bits, which you divided by 8. So you're looking at 424 kilobytes per chunk, and then you want to times this by 25, and then times by 25 again. And you're looking at basically 327 megabytes just for the heat, or just for using a long. And that's not including the fact that we have a radiation map to use, we have a gas map, a fluid map, I'm expecting that voltage is going to dump a gig onto the runtime. That's maximum, by the way. That's not like the minimum. The minimum, the reality of this, even though this looks like a lot of data, divide this by 2 is the maximum you're going to expect to see it ever hit because most of the world is empty. So everything above 128 is normally empty. Now you want to divide this by about 10 again, and that gets you closer to the average. So you're going to see about 16 megabytes average usage per player. When I'm saying per player, this doesn't mean if you have 100 players logged in, this goes up by 100 times. The ideal is that if you have 100 players all separated from each other where they're not close to each other so that each one is loading a 25 by 25 area, they're going to use 16 megabytes each. And the reality of it is that probably still isn't going to quite cover it because the heat is going to be localized, so you'll have a machine that's going to generate heat, and it may only generate heat over like a 3-chunk area. So you're looking at 3 chunks worth of RAM being used, which we already saw was a 524 kilobytes. So it's like a megabyte per player for heat map. You'll be a lot less for radiation, unless you're like constantly nuking each other and dumping radiation of each other. That'll be the same thing. You won't have a lot of radiation going around. Fluids and gases will be something that'll be a little higher on the usage because I'm going to track oxygen levels in tunnels and stuff. So if you're running heavy machinery in tunnels, it'll suck all the oxygen up and your player can suffocate. That'll be something you guys are going to have to keep track of. You're going to want to keep exhaust sucked off of machines in the future. Fluid map. Fluid map is actually going to tie into the block metastructure a lot more than the gas map. So the gas map is going to store gases in an external data structure because this is the reason why I said there's going to be 2 separate ways to access this. Is that this is going to use an external data structure, so we're not storing blocks in the world. So there's no blocks at all in the world that are going to be interacting. This will reduce block updates, reduce TPS. This will reduce the impact on TPS. So you won't have any TPS problems with this. Fluid map's a different story. It may affect TPS slightly, but this is only if somebody's like draining a lake or something. But what it's going to do is it's going to try to map fluids in the world. So you'll have a block of fluid placed in the world. And then the external data will say that's gasoline or that's oil or that's lava or water. So you'll have the ability to store 32,000 different fluids, which is the main reason I want to use this is because we're going to use the metadata for the flow rate so we can continue using the Minecraft renders. But then we're going to use the external data to tell us what we are. So we'll have 32,000 different primary fluids to work with. The reality of it is I may still look at this and I may just use an external data structure to say, okay, at this location we've got 40% oil and then 60% water mixture. And there'll be different ways we'll toy with that. This is something that's most likely going to come way down the road because I don't have a usage for it right now. The only thing I can think of at the moment is going to be in-world smelting of materials, which is something we may bring back in Basic Industries. It was something that was in Resonant Induction back when we still worked for Universal Electricity Team. I kind of want to bring that back, but this is where I was saying where we're going to use the external metadata to make it work. So there may be 2 versions of the fluid map. There may be the gas map may end up being renamed the fluid map down the road, and we'll use it for gases and liquids, but then this one might actually, you know what, I'm just going to call this one the liquid map. And we're going to rename this one to the fluid map. So this will be external data system to track fluid fluid types. So we'll change this. So this will be the fluid maps. This will track a little bit of everything. So you'll be able to put anything in here. It won't care what this is. And then this one will be primarily just for mapping fluid blocks to the system, which means this one won't really do anything. This is just more of an overlay on top of the block meta. So we'll still use the block meta, so this one won't increase the amount of RAM used at all. It'll just use this one, and we've already done the math for the block metadata. You're not going to gain much on RAM usage on this one because it's going to be implemented. Well, right now we're using a cubic chunk system for it, but I'm actually might move to a layered cake style system where instead of having a cubic chunk that's a 16 by 16 by 16, instead you have a 1 by 16 by 16 area. Because the reality of it is you're going to be using metadata, and not a lot of blocks in a chunk are going to use these because we're only going to be using these for like blast code and stuff, so you're going to see very rare usage. Now radar map, I haven't covered a lot when it comes to the RAM usage of this, but this is basically a non-existent RAM increase. The only thing the radar map does is keep track of entities per chunk, so you see maybe a couple bytes increase per chunk of RAM usage. So the worst case that this does is this does affect CPU slightly, but not by much because it is threaded. So it's actually has almost no impact at all. And then that covers pretty much everything when it comes to this to-do list. Eventually, we're going to get on the website. This will be part of the website itself. So you'll be able to go through and track each mod and go like, hey, here's every single thing that we plan to add to this mod. Here's the priority status. Here's how long we expect to take it to do. Here's the status. We may even put a voting and rating system up there so you guys can vote on what you guys want to see quicker than later implemented. Especially when it comes to, which by the way on the to-do system, we do have a bit of the site. All the downloads are going to get a rating system on them. So if you guys start downloading versions of a mod and it's broken, you can go up to the rating system and go, okay, it's heavily buggy, and then that will highlight the download as red for everybody else to see. Of course, we're going to be implementing systems in here to prevent people from trolling the rating system. That is something we're going to do. There'll be a moderator. You will have to actually be logged in to use the rating system, so it is based on that. But it'd be kind of cool because we'll get a whole bunch of stuff going with that. We're going to get a better mod page because right now if we go to the site, which by the way, the site did get a workover on the main page, but as soon as you go to say like add-ons here, then it's back to the old site. We haven't finished updating it here, but this is the mod page. I want to get this to a point where this is sortable, so you can go up to the search bar and you can type in what mod you're looking for, because after all, we do have quite a bit listed here. We have over 200 projects, and you can only see there's only 5 listed here, and there's some work in progress ones. Armory actually needs to go up to this list up here. So a couple of these ones need to go back up here, but nobody's been maintaining the site. We're going to get it database driven, so the database will be able to come down here and I'll be able to go click and remove from work in progress up to primary release. And we'll start having better links to our main download pages. Right now we're using Curse as our main download pages, but if we go actually here and if we go click 1.7 and we click downloads, we do have download pages built into the site. I want to get these more up in front and center so you guys can use these downloads instead of Curse. These will be ad flyed, unfortunately, so Curse, if you don't want to have ad flies, go use Curse. But what we'll have is off to this side here, we'll have a rating system, and we'll go, okay, it'll also show you the number of bugs that have been reported. It'll also tell you the number of bugs that have been solved. So if the previous version had 100 bugs and this one solved like 90 of them, it'll go, okay, there's 10 bugs left, 90 of them were solved. So it'll show up 10 to 90, and then you can report more bugs. So every time you report a bug, it'll go up and counter. And as we solve them or close them, this number will change because it'll be database driven. It'll be part of an issue tracker. The site will have an issue tracker built into it. Right now, when you guys use the issue tracker, you actually will go to GitHub right now for the moment, and you'll go like, I want to report an issue, click new issue, fill everything else out. That will change. We're going to get rid of our GitHub issue trackers over the next year and a half because I am making a game studio and I do not want to use GitHub for my game studio because that will require you to make an account through GitHub and then report bugs through GitHub, and GitHub's tracking system is absolutely horrible for mass handling of issues. Its issue tracker is actually more for developers to use than anything else. So I can go in and make an issue going like, hey, we got to implement this feature or something like that. So the new one will have that. The issue tracker will still be publicly accessible. So you'll be able to go in, make an account, report things. You'll be able to see other issues reported. But what I can do with it, I can do cool things like merge issue tickets together, merge comments, have a bot auto handle things, deprecate issues, delete issues, categorize them. There's a lot of dialogue things too. One of the biggest things we want to get our own issue tracker is that there's no dialogue form. So like, actually, let me use the Mojang one real quick. Cause I think Minecraft has an actual nice issue tracker. So if you go to Minecraft and we go help and we go visit support center. So they show like a whole bunch of issues as well. This is something we want to get up here on the list per mod. But there should be like a create issue ticket here somewhere. Let's just type something random in. Search. Send us an email? Okay, that's not what I'm looking for. They had a dialogue in here where you can report bugs. Because I went through their system here a while ago. Well, that's... I don't get an example for that one. But if you guys have ever seen like Google Docs feedback system, they have forms you can make. So what we want to do with our issue tracker system is we want to have a form that shows up and goes, okay, what is your category of issue you're reporting? What is the mod? And it'll actually ask you each of those questions one at a time. It'll give you really easy handling for it. Because right now, if we go back to, yeah, let's go over to VoltEngine real quick. VoltEngine has something like this built into it actually, and I absolutely hate it, even though it's about the closest thing we've got. So when you create a new issue, it goes, okay, what is the version you want? What's the forge version, etc. But this looks really, really bad because it's not exactly easy to read through. And for somebody who's under the age of like 15, which is our average user base right now for ICBM, it's not exactly the easiest form to use. We want to actually get a really nice one that's really elegant, clean looking, and everything else. But moving on, since I just wasted the first 15 minutes of this video talking about future plans, let's get into actually working on things. Now, I don't exactly have a groundwork plan on exactly how I'm going to implement this, so we're going to guess as we go, which is not the way you're supposed to code, but we'll make it work. So go world, then we want map, block. So we got our extended block map manager. Now we don't have a save system for this yet, so this is something I'm still going to have to implement as well. But we want to synchronize the data over the client. This is going to need a packet handler, and we're going to need some kind of way to track it. Now this is a bit of a complicated problem because I haven't done any research to see how this is done in Minecraft. So I have no clue how Minecraft decides when data is sent to the client. I suspect that it only sends data on block updates. Okay, one thing we're going to need to do is we're going to want to make a differentiation between the server version and the client version. Yeah, do refactor. So we got a server version of this map, and we're going to have a client version of this map. Okay, both of these are going to have to do slightly different things. The client version is going to have to figure out what data we need at what time. So we're going to put an update loop in here. So do public void update, and then what I want to do is I need a few different things here. For starters, the client is actually only going to be a single world. So what we'll do is we'll change this to an extended block data map. So that way we only have one world. That way when you transition worlds, what it'll do is it'll go and request the new world from the server. And, oh, we're going to have to actually make this. What does it want? It wants a manager and it wants a dimension. We'll just go null and then 0. We don't really need to keep track of either one. The manager is only used for saving, I believe. Right now, I think it's the only reason you pass it in. Map manager, yep, it's only used for saving. So we want to go map manager doesn't equal null. Then you want to return null as well. Saving is only done server side anyway, so that would have never crashed, but just to be safe in case somebody doesn't understand how the API works and they try to save something on the wrong side. Okay, okay, we're good there. So we want to do an update method, and this will be an actual event, so this will be, let's change this to world update. And this will be world event dot tick, I believe is what it's actually called. Load, unload, save, potential spawn. Okay, that's not going to work. Server tick event, that'll work. You know, actually, we really need a client tick event, is what it actually sort of needs to be. The reasoning for this is that the client is going to be entirely responsible for telling me what I need. rather than the server telling the client what it needs. So the only thing the server is ever going to do is determine what chunks I need to unload and what chunks do need to be unloaded, which is actually done, I believe. Yeah, we already do some handling for it. World map contains key. Yeah, there's our update stuff. Here's our unload handling. We don't have a load handling, which is something that does need to be implemented here. Load handling is only implemented when it needs to be implemented, or only called when it needs to be called right now. So I think it's actually the get method will actually load the world is how it's functioning right now. Let's take a look at the data map real quick and see what I got for handling in here. We do have chunk loading, unloading, and we do have a world save handler in here. There is no tick updating, so we're good there. Of course, we do the tick updating in a separate thing, but yeah. So what we can do is we can do the update here. This will be client update. And this will be at override, or not override, this will be at event. No, subscribe event, I believe. Yep, right there it is. So this is only going to tick client side. Now the thing is with a client tick event, I think this is called every single tick, even if you're not in a world. Let's try a world tick event instead. And what we'll do is we'll go, okay, if event.side equals side.client. And we're gonna need a packet handler on this. I only want to make one packet for all of the data maps we're going to use, so we're going to make a really basic packet in the core. It's just going to be request chunk data, and you'll tell it what type it is, and you will tell it what chunk you want. And it will synchronize the entire chunk to the client, so it's something that we don't want to lightly do. Although what I might do is I might improve handling so maybe it'll work cubically, because really you only want to sync the extra block data to the chunks that are next to the player or within the view of the player. So we'll toy around with this method. I may make a thread that will predictably figure out what chunks to load and will essentially only request stuff as needed. This will result in some weird behavior potentially, so I will make an option to turn it on and off as needed. Probably by default it'll be off, and I'll let people just turn it on as needed and be like, hey, you turn this on, it will fix bandwidth issues, but could result in some rendering problems. Because reality is the only thing we're trying to fix is rendering. So we want this to be client side, and I have no clue how to do this. That is a really bad problem. Because if I screw this up, then it does result in some rather serious bandwidth problems for the game. Now the thought process going through my head is we have a few options. We can tell the server every single tick what chunks are within view. That's actually not a lot of data to send to the server. Then we can figure out some way to identify how old the chunk is. Probably we'll keep track of some kind of millisecond time of the last edit. Because the big problem is I need to be able to send a chunk to the client if it has been edited. Actually, I know how to handle that one. What we're going to do is we're just going to request missing chunks right now. So we're going to request chunks that are currently in our view range that we do not have data on. And then we're going to trim any chunk that's outside of our view range. This is going to be tricky because I need to prune this map real quick. So I need to figure out what my position is as a player. And this needs to go somewhere else technically. Yeah, I'm going to go throw this in the client proxy. I'm afraid to code a lot of client-side behavior inside something if it's going to be used primarily server-side. We are going to keep this because this is important, because every time you call a get method, if you're client-side, it's going to call to this. Every time you call a set method, it's going to call to this and then send a packet. Well, actually, no, you're only going to be able to get values from the client. We're never going to do a set value client-side, so what we'll do is we'll go really quickly, go world.isRemote. So we're going to prevent the client from modifying the maps. And then we're going to return 0. And we're going to do the same thing here. So world.isRemote. This won't prevent somebody from screwing with it, but it's just a safety mechanism just to prevent stupidity. Actually, we can get rid of that extra one right there. So this will just be a really simple safety mechanism, just so that way you don't get accidental manipulation of the data client side, resulting in some weird behavior. Yeah, we'll be fine there. So this will be fine. The get value, so what we want to do is I'm going to go, okay, if world.isRemote, then we want to call the client version of it, and then else you want to call the server-side implementation. And then you want to return like whatever. So world.isRemote, and then we want to go return if world.dimension. Actually, no, anytime you call to the world, it's just going to go client get value XYZ. We're not even going to bother to even check to make sure the world is correct, because if you're client side and you screw up and you call the wrong world, that is your problem, not mine. So yeah, actually we can even do this real quick. So we can go how do you get the current world for the client? Because I'm not going to do that, because in order for me to do a proper client side check, I am going to have to use client side code in this method, which means I would have to have a separate version of extended block just for the client. I don't want to do that. Anyways, client proxy. Yeah, this will be a good spot to stick it right here. Because the proxy should be registered with FML and Forge, and we'll check in a bit here. But we need to manipulate the dimension ID. So I'm going to go here, and I actually need to make the dimension ID flexible on being changed. Because what we're going to do is when we're in the client proxy, we want to get the Minecraft player. So I'm going to go entity player equals Minecraft.get Minecraft.the-player. I'm actually going to store Minecraft here too while I'm at it. So Minecraft MC equals that. That way I don't have to continuously call that chain right there to get Minecraft, because I'm going to call it a few times. Then we want the world equals MC.theWorld. First thing we want to do is make sure our player isn't null, because there are cases when your player is null. Make sure MC isn't null either. MC doesn't equal null. I've had this crash this way before. It's the only reason I'm actually doing checks like this is because I've physically had the game crash. So you want to make sure the player isn't null. You want to make sure the world doesn't equal null in case he's transitioning dimensions or something. Then the first check, we want to go, okay, if extended block data map. Okay, I got the wrong one. Extended block data manager. .client.dimid doesn't equal world.provider.dimid. So we want to go, okay, if our current world does not equal our one world, then we want to take the current world and we just want to clear it out. So I'm going to do this, and I'm just going to make a method real quick called clear. And then we'll also go extended client, and we'll set the dimension ID. That way we know where we're kind of at. And then we create method, and we want to put this in chunk map real quick. Is there even anything in the chunk map? Yes, there is. Okay, so chunk map, we just want to go clear. So chunks.clear. Really simple method, not really complicated. We want to make sure the dimension ID now equals our new dimension ID. Also, I'm going to put this whole thing in a try catch to prevent the client from crashing. Exception E, and then it'll be engine.logger.error, unexpected error while updating client chunk data state. This is also going to be used for pretty much all of the stuff. So right now we're using it for the extended data system. If we need to sync heat to the client, which we actually are going to need to do because if we have a coloration change based on heat, that is something that will need to be synchronized to the client. Additionally, we may want to sync a few other things. Gas map, we're probably not going to sync to the client because there's no reason unless somebody decides they want to render a whole bunch of stuff. Fluid map, yeah, we already went over the fluid map, so we're not going to really need to synchronize that. Radiation, we might need to synchronize for particle effects. I'll look into that one later. We're not quite done with that one, and to be honest, right now we don't have particle effects. And to be honest, we probably could just trigger the particle effects server side. Okay, so looks good. Okay, so we got it cleared out. Then we want to sort of map what chunks are within range. So there should be a way to get the view distance. I'm trying to think of like the best way actually to do this. I think it's mc.settings.view distance. No, not that. View bobbing, chat, difficulty, fancy graphics, force unit count font. Additionally, what we want to do real quick, we actually want to put this. So I just realized there's something we actually need to do to help out mod pack makers in case I screw up on my end. And it's a configs real quick. So we want to go public static boolean enable extended meta sync packet sync equals true. What this will do is if a client decides he doesn't want to have this extended data, so he doesn't care like to see all the pretty colors and whatever, he can just go, I don't give a shit. And if the server, which I hope never happens, decides that they don't want to have to deal with the extra bandwidth required for this, they can turn it off. I'm going to leave the option in there. Most likely what will end up happening is I'll probably create some kind of notification system. Like when you log into a service, it'll go, hey, your extended synchronization data has been turned off server side. You are going to see rendering issues, or etc. I'll figure it out later. But we'll put it in there and actually make sure I go implement the config load for it, or I'm going to forget here. Where are the configs? Okay, there's the heat map. By the way, you can turn the heat map completely off. It is something that's able to be done. Yeah, we'll just borrow this. What config is that from? That's from the heat data config, so we are going to want to keep it that way. There's an explosive config. Is there just a normal config around here somewhere? Yeah, there's just some normal configs. I'm trying to figure out if we get like a bulk spot. Yeah, right down here. We'll just make a new thing called map configs. So actually, I'm going to copy one of these because this one looks a little nicer line-wise. And then what this will be is enable packet sync. Category will be map data. It would be on by default. Okay, while on, extended meta values will be synced to the client. Can be disabled on both sides, but will result in rendering issues if disabled. We're gonna have to find some way to measure the bandwidth usage of this because I'm gonna get asked by somebody at some point how much data it is using, and I will not be able to give a definitive answer unless I figure that out. We're good there, so that gives us a setting here. We're gonna give settings to turn off all of the maps, by the way, and we'll just have to figure out some way to get around their usage. So we get back to here. I gotta figure out some render distance here. Now there should be a render distance. It's probably one of these untranslated things. There's a gamma. Oh, there's a. I never knew there was a gamma setting. It's probably brightness. Keybinds. Render distance chunks. Here we go. So that's what we're going to use for our system here. Now we need to get the center point. So we need to get center x, which will be math.floor player.posex. Pause z, and then we want to convert this to an integer. If my caps lock didn't just activate, and then we're going to want to convert this to a chunk location. So we're going to wrap that again, and I believe it is bit shift 4 like that. I'll check here in a second. So if we go up to our map, yeah, right there it is. So it's location shifted to the right 4 times. So go back to here. So that should give us our chunk location. And then what we want to do is we want to go, okay, we need to figure out what chunks are within range. So the first thing we need to do is make sure that our chunks are inside of our radius, and then we need to remove them from their knot. And we're going to give a 1 chunk boundary on this. Actually, we'll do I'll do a 2 chunk boundary. So we're going to go for probably chunk data, and then we want to get the extended map here, and we want to pull its chunks. So chunks dot values. So we're going to loop through the data, and we want the location. And this is actually surprisingly the most easiest thing to do. Is we're going to go, okay, if data dot, can I not access the location? Okay, it's going to be position, and then it's going to be, okay, cool. So position dot chunk position x, then minus center x, and then we're going to do math dot absolute on them, and then we're going to go, okay, if it's greater than our render distance, then we just get rid of it pretty much. And what's a boolean? Because I think I added, yeah, as an extra bracket. Okay. For this, we're going to have to use a list of chunks to remove, by the way. And let me check the chunks here. It's chunk position, and each chunk should store its position in there, so I shouldn't have to mess with that. So I should just be able to store the chunk data. And the reason why we're using chunk data and not the extended block map chunk is the reason of I can recycle this code here. And I can go clear all chunks within range, and I could just pass in the map. Chunks to remove. And then we repeat the same exact step for the Z position. To be honest, we actually could just copy this real quick and move it over here and then change the characters from X to Z. Yeah, that'll work, because what we're doing is we're checking if we're outside the X and we're checking if we're outside the Z. So we don't need to know if we're outside of both, we just need to know if we're outside of one. Because if you try to check both, then you'd result in chunks not unloading. So what you're doing is you're unloading chunks client side. Next step is that we want to go for chunk data chunks to remove. Then we want to go grab this guy here, grab his chunks actually as well. And then we want to remove data.position. And hopefully that does work. We'll do some unit testing on this later to make sure this does function properly. More than likely what I'll do is I'll separate this out into its own method when I go to test it. So we'll do this clear out chunks outside of render distance. This is the main reason why the game actually lags, by the way, when you move too fast, is that Minecraft is doing something very similar to this to your client. I'll probably toy around with my version. If I get my version running really, really well, I may take the code from my version and go apply it to Mojang's version. That way you can work out a little better. I do have a plan for if you're moving really, really fast, is that it will go, okay, if your speed is max past this, it'll calculate how many chunks you're moving per tick, and it'll go, okay, he's moving so fast, let's stop loading chunks behind us. Let's start preloading chunks ahead of us, and let's stop loading as many chunks to the left and right, because it's predicting your position, in other words. So it's trying to predict what you're doing. A few other things. I'll add a whole bunch of settings to it and try to make it work as best as possible. But anyways, we've cleared this out. Our next step is to get our X and Y position. So our X is going to be center X minus render distance. And actual render distance here. So I'm going to reset the render distance. Because we only want to request chunks in our actual render distance. And what we were doing here is we set it a little higher so that way we leave a couple extra chunks on the edge, so that way we don't have to continuously re-upload them. So this needs to be less than center X plus render distance. And then of course we're just going to iterate forward. And this will be the same thing for the Z position. And what we'll do is we're just trying to find all chunks, and we're going to go, okay, if there's a chunk that's within my render distance that I do not have, please send it to me. Is what we're going to tell the client, or tell the server. So what we want is we want to grab our map here, and we want to go chunk data, chunk equals this dot get chunk x z, and if it returns null, we want to request it. And then on top of this, by the way, we want to run this only so many ticks per second. There's a way I can track the tick. I always ask this question. I know there is a way to do it. It's a bit of a pain because I never can remember what it is. We'll do that in a second. So we'll go to do reduce check to every 10 ticks. So what we're going to do is we're only going to update so quickly, because you're not going to be able to walk quick enough between where you're standing and the edge of your render distance for me to have to recalculate this. If that is the case, I will change the tick rate, but the reality of it is that not that big of a deal. Like if this fails to function at any given point, worst case scenario is you lose the ability to see certain block types. There still will be a rendered block there, so it's not like it'll disappear on you, but instead of seeing cobblestone, you might see stone, for example, using our heat system. Anyways, if this chunk data equals null, we want to send a packet. So to do send packet. Now we need to create our packet system now that we've coded this all up, although we haven't tested any part of this, so 50-50 chance it works. But we want to then go, let's, if I can remember correctly here. Okay, yeah, network, and then it'll be packet, and it's callback. So we're making a callback packet basically. Packet request chunk data. I went ahead and copied this really quickly because we're going to recycle a couple bits of here. So we want to know the dimension ID, we want to know our location, but our location is going to be an integer, and we don't need to know anything other than that. So change this real quick. So int dim, int x, int z. Actually, we're just going to go ahead and do this real quick. Even though I don't recommend ever doing these inline keys here, it does kind of work out pretty nice. Do that real quick. Get rid of that. Actually, I'm just going to redo this whole thing. This.dim equals dim. This.x equals x. This.z equals z. And then we just need to encode that. I need to transition these to integers. So this will be writing an int. Then we're going to need to make another version of this, which is sending the packet data, which is going to be not so hard to do. It's just I got to make a second packet, which I didn't want to do in the first place. Yeah, okay. I just had to think there for a second. Minecraft world, and then we want to make sure our provider is the correct provider, so if we're sending packet data, it's correct. Actually, no, this is handle client side. We want to handle server side for this packet. You know, I could, in theory... No, I'm going to need 2 packets for this. I was about to say, I could, in theory, write 2 packets and have 2 separate packets, or have 1 packet where this does both jobs, but then I just realized it's going to end up bad. Let's actually make a new package for this. Chunk. Put this up here. So this will be request data, so we're just going to change this to request data. And then I'm going to copy this directly and put this down here, and this will be send data. What I'm going to actually do is tell this to extend packet request data. That way I can recycle most of what's up here. So we'll have this. This will go to super dot. Actually, just super dem x and z. And then, yeah, we'll just do super on all this. Super dot encode into ctx and then buffer. And this will also be super dot decode into ctx and then buffer. And then this will be handled client side only. And how we handle it client side is we're going to make a new chunk. So this will be, we need a type, of course. So we're going to need int type equals 0. So we'll have int type. Type's going to be used to identify what map we're accessing. And then we're going to need to encode the data. Now we have 2 options. We could use a buffer, so we can actually write it to the buffer. Not a horrible idea. Actually, you know how we're going to do this? Is we're going to have a type, and then we're going to go chunk data, data. We're then going to store the chunk data in here. So we'll have a method like that. So go this.data equals data. And then when we go to encode into, we're just literally going to go data dot write to, actually hold on, let me go to chunk data here and then implement there's a method for this and I forget what it's called. It's I byte buff probably. Yeah, I byte writer and I byte buff reader. And then we'll remove the abstract real quick so I can implement these. Implement methods. Put the abstract back. The only reason the abstract's on here is so you can't implement chunk data directly. Okay, and then we'll end up coding these at some point. We're not going to write the position data to the chunk. This is literally going to be used only for writing chunk data. But what we can do here is now we can go data dot write bytes and you pass the buffer in. So you don't have to do anything, you just pass the buffer in. Some of the other packet types I have, we have a separate buffer just for writing data, and then we write it to the buffer, which is a little tedious. This way, we do it this way, it's not as bad. The only difference is then we have to go here, which will be chunk data, data equals null, and then we need to go, okay, if data doesn't equal null, data.read bytes, and this is where the type comes in. So we go if type equals 0, then data equals, what are we actually using for the extend packet data here? Remove that. Extended data manager, we go to the map. Okay, we're using a chunk data short. So chunk data short, put that there, be new. And then we're going to want to read in our location data, which has already been done for us, so we just have to go xz. So we're good there. And we need to check our dimension ID here. So this is handle client sub. So we go, okay, if dim equals player dot world dot provider dot dimension ID. Then we want to go grab extended. Actually, this is where we need to check our type again, because we're going to use this for multiple packets eventually, so, or multiple maps. So we need to go type equals 0, extended block data manager client dot chunks dot put. Actually, we need to change this to this. So this would be data dot position, then data. And then of course you need to make sure data doesn't equal null either. So if it failed to find type, which we'll put an else statement here. Put an else that only shows up if you're in debug mode, because there's a high likelihood that we'll just leave a few things where we'll have types that'll be being sent, but the packets won't be handled in some versions. So you don't want those bugs showing up in the runtime. Failed to ID chunk type while decoding chunk data packet. And we're going to want to prefix this with chunk packet handler, even though that's not what it's actually called, but that gives you a good idea of where this information is coming from. That way you aren't guessing like what's this and what's that. Why can't I do that? Wrong second argument. Chunk data short. Okay, that works. So this gets our handling here, packet handling here. We just got to write the data now, but we can send it. So this is a good way to test it real quick. Now we just got to register both of these packet handlers, which we do in, I believe, the Netty package. Okay, it's not these ones. It's probably this guy. Nope. Last try. Here we go. Cool. And of course, I forgot I actually implemented that nice packet handle system here, so now I don't have to manually pick IDs for these. It'll pick them for me. So this will be packet send data. This is going to be packet request data. So we're good there. Those are registered now, which means they will function. And everything looks good. So I can close these now. Now I just got to go over here and I need to go engine.packet handler, I believe, or engine instance packet handler. Packet handler send to server, new packet request data, and I need dim x and z. So this will be world.provider.dimid and then x and then z. So that part's finished. And then our server-side implementation, we just need to do a few other things. So we actually need to grab this one, and I need to figure out some way to send the packet back, I guess. Probably going to send an empty chunk or something. Trying to think of like the best way to handle this, because theoretically the server is supposed to actually have empty chunks. Yeah, that'll work. We'll just send an empty chunk to the client, because that'll make sure we have something at least. So let's go. We need to get the chunk. Okay, so we got the dimension ID here. So we want to go extended block data manager. dot server, and then I want to get the map for the dimension, dim and then false. So this will be extended block data map equals this. Okay, so first check we want to do is make sure we have a map. So if map doesn't equal null, then we want to actually create a variable up here. So chunk data equals, we don't have a type on this. I just realized that. I'll fix that real quick. This actually means our send data thing can get rid of its type, and then I can send the type to the super and recycle that piece of code. And we're good there. So we want to go, this by default is going to be null. And then our next step is if type equals 0. And then we go down here if data does not equal null. Then we want to send it back down to the system. So we want to go engine.instance, which by the way, I'm going to recode how the packet handling actually works here. So if you notice I'm doing engine instance to get it every single time, that's just because of legacy reasons. The new one's going to be just packet handler.send is what the new one's going to be, but I haven't got around to doing it because legacy reasons. So we want to send to client, or send to player, and it'd be new packet send data. This is of course going to be dim xz type, so we're just going to recycle the type and data. So that's literally how simple that is, and then you just throw player in there so it identifies the player. Also we need to do make sure player is instance of entity player MP, which it should be by default, but I don't know why it's not cast that way, and legacy reasons I'm not going to change it. Entity player MP, there we go. Actually, legacy reasons I probably could fix this. Because this is called from here. Get client player entity. Yeah, it's a multi. Oh, that's the reason we pass it in as this, because there's a client player here, and client player is actually entity player SP, I believe. So we can't actually use separate methods for this. Okay. What are we missing here? Oh yeah, we're missing the type. So type is 0. We'll probably switch that to an enum later. Right now it'll work. So back to send data. So if we don't have a map, we're just literally going to go and we're going to say data equals new chunk data. Apparently I need to do chunk data short. Chunk data short. And this will of course be x and z, so it'll log its location properly. But what we're doing is we're just effectively sending an empty value down there. Next step is going to go map.getChunk. So go data equals map.getChunk, and this will be x.z, and of course this will be null by default if it is. What we actually want to change this to is if data equals null. Yeah, there we go. So that way this will cover two cases. It will cover if the map is null, and this will cover if the data is null. So this is that simple. You get a chunk. It'll grab it from there. It's going to be empty by default. Made sure to make that notation in case an intern goes through there and like, hey, let's change this to create the chunk by default, and it screws the entire packet handling system up. Actually wouldn't break the packet handling system, but you guys get the idea. So this will send our chunk data to the client. Yeah, it looks good. Might be a bit spammy, maybe. We'll have to test bandwidth. And then the next thing we want to do is write the chunk data. This is the somewhat problematic part, is that we have chunk sections for starters, and we got to write those in there, and then we have a few other things. Let's close that, close that. I haven't even finished writing the load save code anyways in here, so this is going to be interesting. We don't want to save via MBT, even though MBT is actually surprisingly a very good format to use. We're running a bit long on this video too. We're almost done though. So we want to loop through the sections. We want to make sure the sections are not null on our write method. But then we want to write the sections to buffers pretty much. This is where the complex problem comes into play, is that I need to write 16 sections to a byte buffer. Now each section should be the same length, so I shouldn't have to really worry about too much, because after all, we're just going to write a short array to the system. Let's go ahead and implement I byte buff writer. Yeah, we'll do both actually. Buff reader and writer. Implement both methods. So we're going to read byte buffs. So it's going to return this. Now I need to return the buff down here. Now you change this to chunk section short. So when we write it, we need to determine what the ID is. So when we go to write this, we're going to do buff.write integer I, and then we're going to go section.I.write bytes to the buff. Now, if this works correctly, as soon as the first thing it should read is the ID, then it should read all 4096 shorts, then the next one should be the ID again. That's in theory how it should work. This is going to probably backfire on me, which means I'm probably going to have to end up using MBT anyways for the simplicity's sake of this. We also need to check to see if these are empty too. That's actually, you know what, I'll do this check to see if these are empty server side, because if I get an empty chunk, I'll just wipe it. I'll get rid of it. But next one we want to do here, we also need to write how many sections we actually are going to have. Yeah, I know, I'm just going to save this via MBT because it's going to take me too long to do this for this video. So we go MBT tag compound, MBT equals byte buff utils dot read tag from buffer, and then we just want to go load. Yeah, we'll just do it this way because this is going to be the fastest form to get this done. And then I will recode it later, because if we can get it writing just in bytes, it will cut down probably about 20% off of our total size, if not more. Because you remember, we have to encode strings and a whole bunch of other stuff in there, which we don't really need. So we'll get ahead, taking that care of. And this will be save tag, and this will be byte buff utils dot write tag. So buffer and then tag. This does mean we'll have to finish our reading here. So reading is going to be MBT tag list equals MBT.get tag list. We're looking for the tag list sections, and then our type is going to be 10. 10 is MBT tags, by the way. We want to go for int I equals 0. I is less than list.tag count I++. And then you're going to read this basically backwards. So MBT tag compound tag equals list.get compound tag at I. And then you want to go and you want to get the section ID is the first thing we want to grab. So int section equals tag.get tag, or get integer, I believe is what we coded it as. And it'd be section ID. Then we want to go sections.section equals new. Actually, what we want to do is we do a null check. No, actually, we're just going to clear sections here. Can you actually clear an array? That's actually... Maybe? Because what we want to do is anytime you call load, we want to empty out the section here. Let's make a method for this, public void clear. And you want to go for int I equals 0, or actually, yeah, no, we'll do it this way. Int I equals 0, I is less than sections.length, I plus plus. And then section.I equals null. To do, because what we might want to do is we might want to clear the data contained within the section before we null it out to help the garbage collector clean up. It's not really required, but it is useful. And then we want to clear here so that way we get rid of extra data. Because what we're doing is we're rereading this array from memory. So we want to make sure we got new stuff here. Chunk section short. And then we want to go... we haven't finished the save on this. I just realized that. Sections not save. Actually, no, we did kind of do it. It's actually... The section handles its own saving and loading, so this will be load MBT. So that'll work. So now we got our load, we got our save, we got our packet handling. Now we need to go to each of the sections and make sure the sections are doing their jobs. We can get rid of this. We're not going to do it this way right now. So now we need to save and load this, and I don't think there is an easy way to do that. Could do a byte array. Actually, hold on. Let me Google this real quick. Java convert short array to byte array. Because if we can do that, then we can save ourselves a little bit of time. That actually will work. Yeah, that actually worked really, really well. So what we're going to do is we're going to save here. So we're going to turn into a byte buffer, which ironically is the packet handling we would end up using anyways for this. So we go in, so this would be data.length. And then we're going to go for int I equals 0, I is less than data.length, I plus plus. Then we want to go data, so we go buffer.put I. And then get rid of that because we don't need that. So we're just going to write the whole thing to a buffer, and then we need to turn it back into a BB array, which they do right here. So they go BB array. So we're going to go mbt.set byte array data, and then we want to do byte buff.array. So that gets us our save. Now we need to do it in reverse, which I don't think they put in here anywhere. And then you got a guy who's going like all out with like complicated things. Put short to array. So now we want to load it out. So let's go ahead and get our byte array loaded first. MBT dot, this would be buff equals, actually we're just going to call this array. So MBT dot get byte array data. And actually, what we want to do really quickly here first, we go data dot has, or no, mbt dot has key data. So we want to make sure it's actually there. If it's not there, then we don't even bother reading it. So now we need to create a byte buffer, I guess. How do we? I would do this in Java. So Java byte array to short array. Okay, shorts equals byte. Okay, short equals byte. Get shorts. Okay, so we got payload, wrap order, big ending, short buffer as buffer. Oh wow, they even actually do the whole buffer thing. That's kind of cool. We'll do it this way. Change this to payload. This is like my lack of understanding of byte buffer arrays, which I should probably study more, because there's some probably cool things we can do with this. We need an integer, so a equals 0, and then we want to go I plus plus. By the way, when you're putting the plus plus at the end of the I, it's incrementing after you use the integer, so the first one will be 0, then it'll turn into 1 up here after on the next line. Useful to know. Is it sp.get is what they... Yes, sp.get. Okay, cool. So this should work. I would say we should unit test this, but YOLO. Just go ahead and run Minecraft. End this video out. If it works, it works. If it doesn't, I go unit test and I make another video showing it off later. But a lot of stuff to get just packet handling working, and we have no clue if any of it works at the moment. So a lot of testing is going to need to be done. Now the good thing is I can unit test both these, so I can ensure that these do work, and I can work my way from this upwards, so I can go then check to see if the chunk saves, I can then check to see if the entire map saves appropriately, and then I can check to see if the packets read and write correctly. I can't actually see if the packets function completely correctly with JUnit, because I haven't figured out how to do that yet, but I can check to see if they read and write correctly. That's a good step. Actually, I can probably check most of it. I'm thinking about it. I just would have to fake a few parts, because when I do my unit testing, I don't have a full Netty system running, because I would have to initialize the whole Netty system, and then I would have to make a server and client to run, and I'd have to pass packets back and forth. And we're not testing Netty here. We know the packet handling does work in Minecraft. The trick is does the packet itself work? So we can test the packet itself with JUnit testing, which I will do here probably tomorrow, because I'm running out of time today. Unfortunately, I got 2 classes today. And before those classes start, I got a bit of work to do. I wasted most of my morning cleaning, so moving exercise equipment. It's amazing how ingenious you have to get to move a piece of exercising equipment that has only one wheel on it, and you have to move it around a whole bunch of objects without damaging said objects. I really wish I had more ropes and pulleys. Would have made that so much easier. It wasn't too heavy of a piece of equipment though. I think it was only like about 170 pounds. Although I need to move that punching bag that's in there, so I can weld some heavy weights to the bottom so I stop knocking it over when I hit it. Really sad part is that punching bag is actually my brother's punching bag, and he doesn't use it. So he spent all this time and money buying it, and we went over to my dad's house and built a frame for it. Not a really fancy frame, it's just a couple pipes with some bolts drilled through them. Probably should have built a welded frame and actually built a proper tripod for it, and then got some nice heavy weights for the tripod, because my brother's still convinced if you get a tripod you will be fine, but I keep trying to explain to him with the terms of physics, the tripod will not help you in this case, because it's not the surface area that is the problem right now. It's the fact that when you go to hit the punching bag, it carries the momentum forward, dragging the top of the the frame backwards, which then drags the two front legs off the ground when you hit it. So it's literally just a matter of the two legs are not heavy enough. They don't have enough weight to hold the bag to the ground. Oh, that's right. I was I was testing on a slime island. This was fun. So what we want to test is, of course, the nuke. This is what all this work has been for, is to get the nuke actually up and working and functional. And I'm trying not to take the hard approach. I've watched so many devs do the hard way to do this, and even though I'm not, the way I'm doing is not much better. The way they would do it, it would be a constant maintenance nightmare. So here's the nuke. So grab that, and then we want to grab the rocket launcher, and we'll just go shoot some sand. Yeah, I don't even know if the heat system can turn sand into glass. That might be something I'm going to look at doing. And my audio is really low. Always seems to be a case when I'm working at night, I turn the audio down really low because I can hear it later at night. And then during the day, just for some reason that audio doesn't hold up. Definitely need to make myself immune to that. Okay, so I'm seeing some heated stone here. I'm not seeing heated cobble. Are you? What are you? You're cobblestone. You're heated brick though. So I can't tell if it's working. So I guess I'll have to make another video here later showing this off, because I can't confirm if it's functional based just off of this. Because what I would need to do is ensure that the cobblestone is working, and I think there might be something wrong with the heat registry when it comes to cobblestone. So I'll get back to you guys later with more of this stuff.